Assalamualaikum. We continue with part 2 for radical polymerization. Okay, proceed with the redox initiator. Okay, in this one is the structure for H2O2 plus iron 2 plus to form the OH together with iron 3 plus and OH with the radical. So this one is the example of redox initiator. As we can see, the initiating radical are formed by electron transfer from ion 2 plus here to the peroxo compound here. And we can see that iron Fe2 plus is oxidized to become the iron 3 plus, and it is oxidized because it lost of the electron from 2 plus to 3 plus. And the peroxo link is cleaved with simultaneous formation of a radical and an ion here. Okay, and next the oxidized metal, which is the iron Fe3 plus, is reduced again in the second stage to the iron 2 plus state by the hydrogen to form the peroxy radical and a proton. So only a very small amount of iron 2 plus ions is required to generate the radicals. This one is soluble in water. It can also work in organic solvent. Low dissociation energy then can proceed at relatively low temperature. So we can determine which one is the have been oxidized and which one have been reduced. Okay, so iron 2 plus is being oxidized because of the loss of the electron. Okay, we look at the photoinitiators. Radical polymerization can in several cases be initiated by subjecting the unsaturated monomer to light or high energy radiation, for example X-ray, gamma ray, and ultraviolet. And the radiation is independent of temperature, can control the rate, degree of polymerization, and number of cross-linking. And the photoionization is limited to thin layers due to the low penetration of the light. The photopolymerization is used for coating of metals or woods and also in application in dentistry. And the typical initiator are disulfide, benzoin, and benzyl. So we can stop the reaction by simply removing the light sources, and it has a better control of polymerization reaction. The advantages of photoinitiation are the reaction is essentially independent of temperature, thus the polymerization can be conducted even at very low temperature. We have the better control of the polymerization reaction because narrow wavelength bands may be used to initiate decomposition, and the reaction can be stopped simply by removing the sources of the light. Now we look at the decomposition of the photoinitiators. Okay. For example, in benzoin. So we can see the example. It can be direct irradiation of this monomer. Okay, we have CH2. For example, if we have a styrene structure here attached, so it will decompose into the CH double bond together with the radical. Photochemical initiation involves the direct excitation of the monomer or photolytic, and the photochemical initiators include a wider variety of the compound. The benzoin structure, the breakup is happen at the single bond here, so it will be separated to form CO together with CH and OH. And don't forget the active site. And this one, for this structure, it have two possibility, whether it can break at the single bond here, or either if you have another structure behind or in front of this structure we have a styrene structure. So the styrene structure it will break up at the double bond. Okay, and the product yield is styrene, which is the benzene ring together with CH and CH2. Okay, CH2 together with the active site on both carbon atom. Okay, we've done about the composition of initiation. Now we proceed with the inhibition. Inhibition is the completely separation of polymerization by adding an inhibitor to completely stop the polymerization. For example, of the inhibitor are oxygen and benzoquinone. So inhibitor is often added to monomer during the transportation and the storage to prevent self-polymerization, and it must be removed before any free radical polymerization can be done. Inhibitors are compounds that react very rapidly with every initiating free radical as it is produced, and it reacts with the initiating radical species and converting them all efficiently into unreactive substance. After all the inhibitor is used up, polymerization proceeds at a normal rate. Inhibitions lead to an induction period where no polymerization takes place at all until all the inhibitor is completely consumed. After that, the reaction then starts with normal rate of polymerization. Monomers are usually transported and stored in the presence of inhibitors to prevent premature polymerization. Thus, it must be redistilled and purified prior to use. An excellent inhibitor is diphonyl picrahydrazine or DPPH. Now we look at the retarder. Retarder we use to reduce the rate of polymerization by slowly reinitiate the reaction. For example, we can use oxygen and also benzoquinone. So if the generated radical is less reactive than generated radicals, retardation takes place. So when the retardation occurs, there is decrease of the polymerization rate, and the retarder active throughout the course of the polymerization. And most useful retarders is nitrobenzene. Okay, now we proceed with the mechanism. Okay, the challenging part of the radical polymerization process is the mechanism. The mechanism of free radical polymerization involved we have three steps, which are initiation, propagation, and termination. For the initiation step, is of two elementary reaction. First, we have dissociation, which is the formation of the initiator radical, and the second step is the addition of the initiator radical to the monomer. And the next step is the propagation process. So propagation process is the addition of the monomer units to the growing polymer radical and together with the radical itself. Okay, and the monomeric unit joined together by covalent bonds interchange. And the addition of monomer radical to another monomer molecule with the presence of the radical. And during the propagation process, the placement of monomer is whether head to tail and also head to head placement, and during the termination and for the head to head placement it can occur, for example, during the termination by combination. Okay, so for the termination process, Propagation will continue until some termination process by reaction of a polymer radical with another polymer radical or with a primary radical, or also known as a primary termination. So for termination, we have three types of mechanism, which are by combination, by disproportionation, and also by chain transfer. So we look at by combination first. For termination by combination, it is the combination of monomer radical which leads to initiator fragments at both ends of the polymer chains. And termination by combination is the most important mechanism of the termination. Two growing chains together will join to form a single polymer molecule. We call it as a dead polymer at their free radical end. And for combination, the polymer produced is in a head-to-head linkage. And the initiator group will cap both ends of the chain by the covalent bond. So next I will show you the how to draw the mechanism correctly. For the disproportionation, it occurs when the hydrogen atom is transferred from one chain to the other, and two terminated chains are produced, which is one chain will have unsaturated carbon group, which is double bond, and the other is fully single bond or saturated. And for the last one, chain termination by the chain transfer. Termination by chain transfer, it occurs when a chain stops growing, okay, but the polymerization does not stop because a new radical is generated. And it can happen by the hydrogen abstraction from an initiator, monomer, polymer, or solvent molecule. So the radical character of a macroradical is transferred to another moiety, and if this then become able to add an additional monomer. Okay, I will explain in the next video about the mechanism involved in this radical.